So we ended on in the last video, we ended with talking about angular velocity. But what if we looked at the change in tangential velocity over the change in time? What is that going to be? Well, that's the tangential acceleration. This is just going to be, again, r omega over delta t, and r is not changing, so this is going to end up being r times delta omega over delta t. Let me make sure I put my vectors over my omegas. And so now this is what we're going to call angular acceleration. So angular acceleration is just the change in omega over the change in time. That's going to happen when we have a wheel that's going to, or something that's going, and that has some circular motion. Let's just say it starts off with a certain angular velocity, and then later on, it has a different angular velocity. Now, in our experiment, the angular velocities really aren't going to change in this particular case. So if that is so, we know that our angular acceleration is going to be, since this is omega f minus omega initial over t, we know that this is just going to be 0 if omega f is equal to omega initial. Okay, so that's going to be 0. So the only thing that we'll probably end up having is our centripetal acceleration. And centripetal acceleration has to do with a center-seeking acceleration. Haven't talked about that at all, but it is center-seeking, and it looks like this. It's v squared over r. So that's going to be tangential over r. So this centripetal acceleration is, we're going to use this as well in our calculations. Now, I look at it like this. I say, well, what's the resultant acceleration? Well, the resultant acceleration is just going to be the centripetal squared plus the tangential squared. So they're two vectors basically, and it's going to produce a resultant. But since our tangential is just 0, okay, we just end up with centripetal. So it's somewhat superfluous for us to actually do that, okay? So this is the theory. Let's just go ahead and get our data and take that data in. Or better yet, let's just go back to the sheet here, and you'll see average angular velocity. And then you have resultant acceleration. Now, let me ask you guys this. Will the angular velocity increase as we go out along the rod? I want you to take a guess. I want you to think about it, but make a guess, make an educated guess. And then will the resultant acceleration increase, or will they decrease, or will they stay the same? Which one do you think they'll do? Increase, decrease, or remain the same. Okay. Now, if you have something else that's, where they're going to increase and then decrease, and then they're going to come back and they're going to come, if you're going to say it like that, that's fine too. But these are the three options that I want you all to choose from. Increase, decrease, remain the same. All right, I'll stop this video right here. And once I do, what I want to do is we're going to put the data in the next video.